Think about verifying a signature at a bank or unlocking your phone with your face. The real question there is not what category is this, it is a comparison. Is this new example the same as the reference we already trust? Standard classifiers are terrible at that because they need a fixed set of classes and lots of examples for each. A Siamese network flips the whole framing. Instead of learning categories, it learns a general sense of similarity. Let me walk you through how two identical branches make that possible. The name comes from twins, and the architecture really earns it. Follow the pair of inputs through the setup, one stage at a time. Begin with a pair of inputs you want to compare. Maybe a couple of photographs or a couple of signatures. Each one is about to travel through its own copy of the same encoder, side by side, like parallel lanes of the very same road. Here is the defining twist. The reason it is called Siamese in the first place. The two encoders are identical, and they share the exact same weights. That is not a small detail. Because of that sharing, both inputs are mapped into the same space in a perfectly consistent way. So whatever transformation one input goes through, the other goes through the very same one. That is what makes their embeddings directly comparable. Each branch turns its input into an embedding, a compact vector of numbers that captures what the input really is. Now, the whole comparison lives in that vector space rather than in raw pixels or ink strokes. Two photos of the same person should land near each other. Two different people should land far apart. Finally, measure the distance between the two embeddings using something like Euclidean or cosine distance. A small distance means the inputs are similar. A large distance means they are different, and you set a threshold to decide. That single number, not a class label, is the entire output of the network. To really see why this matters, contrast it with the classifier you would normally reach for. A standard classifier learns a fixed set of classes, and it needs many labeled examples of each one to work well. Add a brand new class tomorrow, or a person for whom you have only a single reference photo, and you're stuck retraining the whole thing because the model has no output slot for anyone it did not see during training. A Siamese network instead learns what similar even means. Trained on pairs with a contrast of loss, it pulls matching pairs together in the embedding space and pushes mismatched ones apart. Because it learned a general notion of closeness rather than a fixed list of categories, it can judge a class it never trained on from just a single reference example. Now, let me distill the whole idea into 3 points worth carrying with you. Twin encoders share one single set of weights, so both inputs are mapped into the same embedding space and can be compared fairly, side by side. You compare by distance between the embeddings, not by class labels, which quietly turns the whole recognition problem into simply measuring how close two things are. This makes it perfect for many classes with only a few examples each, like signature and face verification, and recognizing something from a single reference photo. Let me wrap this up with 4 things to remember. A Siamese network compares two inputs and outputs how similar they are, rather than classifying one input. Its twin branches share weights, mapping both inputs into the same space, so their embeddings are directly comparable. Trained on pairs with a contrast of loss, it learns similarity itself rather than a fixed list of classes, which is exactly why it handles brand new classes so gracefully. That design powers signature and face verification, duplicate detection, and recognizing a class from a single example. If breaking ideas like this down into plain language is your thing, you will feel right at home at standarity.com.